Well, I love kinematics and projectile motion. This is probably the easiest thing to do in physics. All you need to do is remember a couple of equations, and they'll probably just give you 3 out of 4 of them, plug it into the equations, and you get the answer. Pretty easy. So let's take a look. All we need to do is look at the first equation. V equals V naught plus AT. This right here just symbolize that this is the final velocity here is equal to the initial velocity plus the acceleration times time. Well, that's just going to be the first equation. Like I said, this stuff is pretty easy. Let's take a look at the next one. All we need to do is square this, so V squared, and then we got V naught squared plus 2A instead of a regular A, x minus x naught. Again, they're just going to give you a couple of these variables, you plug it in, and you just get the answer out of this. Don't really know if I need to explain this any further, but you can see how we went from here to there is by squaring everything. All right, squared, and then here's 2A. Great. Okay, now let's move on to the next step. Here, let's integrate this equation. If we were to integrate this, on the left side, we're going to get x minus x naught, all right? And then on the right side, we're going to get v naught t, and then plus 1/2 a t squared, because you're going to square the t, divide it by 2, and there you go. So we're just integrating this by over t, and there's a whole bunch of math that goes behind this, but let's not worry too much about that. Let's just memorize these equations, and it'll be really easy to solve anything that you need to do. All right, so anyway, now we have our third equation. Like I said, there's not too much stuff to worry about. I mean, I'm sure you can go and figure out how to integrate all this stuff, but I don't think that's so necessary, you know. Anyway, so let's go on to the next one. This is going to be x minus x naught equals vt minus 1/2 at squared. So that's going to help if you know final velocity. This helps if you know the initial velocity. The next one is going to be x minus x naught equals, what's it again? So 1/2 v naught plus v. And that's asking myself is how can I rewrite this vt can be rewritten like this, vt, right? Vt, and then you just, I don't know, there's a half right there. So it's just kind of remembering these 5 equations and sort of these little tricks to go from here down to there is just integrating this side, right? And then you just kind of remember these. The way to remember this is to write it out like 100 times. You just write these out 100 times and then you remember them. Rote memorization, I believe, would be great. It's just a couple of equations. It's kind of like the quadratic equation. Once you've memorized, honestly, just this one, because remember how I got all the other ones just by using this one in the middle and then squaring it up to here and then sort of breaking apart this vt into 2 little pieces here, remembering this is always x minus x naught. So that's great. Like I said, this is really easy, the easiest part of physics. Hell, we're almost done. I'm just making this a little bit more complicated than it needs to be. Let's just say this was 0 acceleration. You had constant velocity. There's another equation you can kind of pull out of this. You can say, I guess it comes from this one. There's another equation you can pull out, but it looks really similar to this. I'm just going to put a diagonal arrow. So x equals x naught plus vt. Great, that's another, and this is if acceleration is 0. This is another equation that comes from here just by cutting that out, and obviously this is the initial velocity here. But so you can see how there's another equation you can sort of pull out if acceleration is 0. Sneaky little trick right there. Yeah, so let's do a little bit of an example over here, I guess. Let's say you were doing some projectile motion and you shot a little ball and it just kind of flew over here and you were trying to figure out how high it went. There you go. We're trying to figure out the y, the maximum height. That's when velocity is equal to 0. This is up here. Why is it equal to 0? Well, because I mean, in the y direction at least. Obviously, the velocity in the x direction will be moving, but in the y direction, it's done. It stopped moving upwards at that particular point, so that's why it's pretty much done moving there. Now, if we were to use one of these equations, what equation do you think we would want to use? Well, it's probably just going to be this top one up here, because we know that the final velocity is 0. We can plug it in right here, and that's just going to be 0. So let's write that. V squared equals V naught squared plus 2a, and then this is going to be y's instead of x's, so y minus y0. All right, and then we can try to plug in 0 over here. This will go away and become a 0. We need to figure out what V naught is, but V naught, what does that really mean? The initial velocity. Because guys, isn't there two components to this? There's going to be this way, which is the x direction, V naught in the x direction. And there's also like this part, which is going up here, which is V naught y. That's really the only one that matters here. V naught x doesn't have anything to do with the y direction. So let's just focus on V naught y. Remember how to solve this? This was the opposite side. This is the hypotenuse, which is what we know. So this is V naught right here. So basically it's V naught sine theta. Okay, and that's what we're going to square. If we need to remember how vectors work, there's another video that I explained how to break these vectors apart into components, so you can go ahead and rewatch that if you need. I'll go ahead and leave a link in the description as well. But anyway, in order to continue this, we just go ahead and add 2 and then g, right? Because it's gravity, that's going to be the acceleration that's pulling this stuff down is gravity. It would actually be minus the gravity. And of course, y0 is nothing because we started off at 0 from the y, and then we're going to end up with final y. You can rearrange this and you'll figure out what the y is. So, yeah, that's how you can solve for y. If we were to solve for x, there's two ways that you can solve for x here. You can use probably this equation right here, which would say that, you know, x minus x0, and of course x0 is 0. We're just going to rewrite this. So vt plus 1/2 at squared. We know that there's no acceleration in the x direction. So, oh yeah, that's right. We can use this simple one right here. All this stuff goes away. Hell, we can just cancel this. That's why I kind of like kinematics. It's so easy. Everything just kind of cancels out. But you're just going to use this equation, x naught plus v naught t. The only problem is we don't really know what t is. So in order to figure out t, you have to do kind of a little bit more solving and figuring out things based off of y. You know, like, now that you know what y is here, you can plug in y over here to figure out what t is. It's just a little bit more complicated stuff. But there's a simpler equation if you don't really know let's use this one. I'm going to write it down first. This is a range equation. X equals v naught squared over g sine of 2 theta. This works if the initial ball lands at the exact same height over here. You can actually just use the range equation. Otherwise, like I said, you have to kind of manipulate y's and try to figure out what the t is, the time based off of y, with some more solving. It gets a little bit more interesting, a little bit more fun. But anyway, where are we at here? So instead of doing all this with the t's, and of course this goes away because it's just going to be x equals v naught t. Remember, x naught is 0. And what is v naught again? It is actually x equals v naught cosine theta t. Let's just, you know, make that pretty clear because it's the component over here. Anyway, so that's how we can solve for y, that's how we can solve for x, and here's y, just so there's no confusion. This is how we can solve for y, and this is how we can solve for x. And yeah, so the range equation, all you got to do is just plug this stuff in. Remember that V naught here is V naught cosine theta. And I think this is pretty much what you need to know, mostly for kinematics and projectile motion. Like I said, it's relatively easy. So, you know, try to write out these equations like 100 times. Once you've memorized these 5 equations, maybe even a range equation if you want, then it gets pretty easy to solve all these problems. It's just a little bit of algebra. Though usually I think, you know, people just kind of get worried about what equation to use, I guess. I'm not too sure. Yeah, I think this is relatively easy. Make sure to like and subscribe. And if you want any kind of like solution to one of these kinematic problems, then just, I guess, post it, and then I might be able to help you with it. I hope you enjoyed this video. Thanks for watching.